what we believe is going to happen is every product, and by product I mean every chemical and material, will be touched by Kimia's chemical intelligence at some point in its life. That could be at the beginning when you'll think about the creation and the discovery. It could be at the point where you're thinking about the regulatory kind of constraints of it, and then all the way to sales distribution and creating something much more sustainable. Once we can get towards that, I think the world will be very different.
The first time we met, you told me about how you wanted to build this thing called chemical intelligence. And you said that in a world where chemical intelligence existed and Kimia had built it, it would be the first AI system capable of winning a Nobel Prize in chemistry. So maybe to start, just tell us what chemical intelligence actually means.
Yeah, maybe just to talk about, I guess, the background of why chemical intelligence. When you think about the world of chemistry or the chemical industry as a whole, regardless of the industry that you care about, automotive, energy, pharmaceutical, transport, cosmetics, they all have something to do with the world of chemistry. And what that means is the byproduct of everything we think about in terms of formulation in the lab, regulatory, marketing, needs to be in sync so that we can have the best products for everyday use. A lot of that process right now hasn't really changed in the past 100 years. So maybe to even give you a quick story about how random things are in this industry. So my dad did his PhD at the University of Wollongong with this scientist called Alan McDermott, and he won the Nobel Prize in, I think, year 2000. And the way that came about was he was working on this project to be able to find new materials that would be conductive. So new type of, I guess, products that would carry electricity. And then on the other side of the world, there was another scientist who separately was working on another kind of project. One of his students ended up pouring, I think by 1,000-fold mistake, this chemical into what they were trying to create, and they ended up with this kind of metallic, shiny looking thing. Alan McDermott happened to be in Tokyo for this conference. These two meet during the coffee break, and then he's like, "Hey, what is this shiny thing? It looks like metal, but it's actually not." And that was the beginning of basically them two kind of working on this, start testing, and then they realized with a few tweaks, they ended up turning this material that was not conductive into something that was 10 million times more conductive, which is crazy. So if they hadn't met at this coffee break at this random conference, we probably wouldn't have flexible sensors. We wouldn't have biosensors, all the things that TVs, LEDs, OLEDs. That was a byproduct of this new class of materials. So that's what essentially the mission of Kimia is. We want to remove that randomness. I think there's still going to be a lot of discovery, but it can become more intelligent. So it will become about access to intelligence rather than just randomness. So that's what we're trying to build, chemical intelligence. And I think if we can succeed at doing that, I believe every chemist would have a shot at creating something as significant, a breakthrough that is worthy of a Nobel Prize. They might not win it, but...
So before we dive into Kimia's vision and where the company is going, it'd be super interesting to hear about how you entered the world of chemicals. You mentioned your dad was a chemical engineer, but just tell us about when you first started being interested in chemistry and how that evolved.
Yeah, so being born into a family of scientists, so my dad was a chemist. He was the youngest professor at his university, and that kind of gives you an indication of what the conversation at dinner tables was always about. And then my mom was a scientist, more on the biochemistry side of things. So I guess from a young age, that was really the world I was brought up in. My dad transitioned away from the world of academia into his kind of own manufacturing, which brought a lot of, I guess, challenges in its own way in terms of commercialization of products. I ended up, again, no surprise, doing my own, kind of thing in chemistry, did my PhD in chemical engineering, and I was collaborating with my dad on a few of these projects. So that became actually my first company, developing this new class of detergents that would allow you to clean cars without a drop of water. And then, I guess history led me here. But I think it was basically the story side of it, just being in a family that happened to be doing this, because chemical industry is very opaque. It's very, you don't just see an average person walk into this industry.
Yeah. And tell us about the early days of Kimia. Like, when did you first realize that software had the potential to rewrite the way that the chemical industry, which is largely operated in the same way for 100 years, this was possible?
Yeah, so when, I think it was like, the early days of ChatGPT, I was talking to Sajjad, my cousin, my co-founder now and CTO, and I basically went to him with one of the challenges, one of the problems that I had seen during my times, collaborating with my dad around understanding raw materials, and in this case, substituting raw materials. So if, let's say you're developing a new type of paint that, is protective for, walls and construction, usually 15 to 20 different ingredients. If for whatever reason, one of those ingredients becomes discontinued, prices 3x for, supply chain issues, sustainability reasons come in, finding an alternative to that one thing, it's months of work. It's not as easy as saying, hey, I've got a shoe or a t-shirt, let me just find another similar one, similar color, similar size. That was the problem. And then basically over a weekend, we started, working with Sajjad on different ways that we could understand a little bit more about this space. And it was kind of like an early days of like a recommendation engine. Like I didn't even really have a lot of understanding of what that whole field was. Obviously Sajjad did. And that was the genesis of Kimia. So what we realized was currently there is no way to actually understand the world of chemicals, the things that have been out there. So there is no catalog in the world of all of the raw materials. There are no tools that can go beyond this like retrieval and actually understand the reasoning behind why chemists make certain decisions as it relates to these ingredients. And that was the beginning of.
And why is that? Are these chemical companies sort of closely guarding their secrets and their formulations, or no one's bothered to put it all in this database? Or why is it such a sort of opaque world?
Yeah, I think initially it was a lot of proprietary, security, kind of safety, which is quite surprising to me at times, because, chemical industry is one of the very few industries where reverse engineering is really not a threat, right? Like if you think about a lot of the electrical components like hardwares, iPhones, you could easily understand what's inside it, right? Open the back, have a look at the components. In the world of chemicals, there are no machines that you could just put, a gallon of paint and understand exactly what the formula is. You can understand components of it. It's got resins, it's got pigments, it's got, anti-UV kind of additives. So yeah, I think initially it was that. I think the second reason probably would be because of the diversity of the industry. So you have various different industries within the chemical industry, right? Automotive, things that matter in a car, for example, the car bumper, the component that goes there, or all the different types of adhesives that are used in the engine to keep the engine running and cool and efficient. And then you compare that to what goes into a lipstick and a cosmetic kind of situation, and then you compare that to a battery. These are also different. So there are no one, unified way to look at this. So all the tools that were implemented in this industry were quite generic. They were like the ERPs of the world and generic CRMs, and they could just do so much. So they had to retrofit products and tools that were used in other industries, mostly the world of commodity, right? Whether it's commodity chemicals or commodity things like e-commerce, t-shirts, and they're just much simpler. So if you think about t-shirt, the only thing that matters is maybe cotton, the material and the size, availability. The world of chemicals is kind of like, instead of 3 dimensions, there's hundreds of dimensions. There's hundreds of attributes that talk about that chemical. And then on top of that, you have different companies calling them different things. So you have like this apple and orange situation where there might be similar thing, but you've got to spend time to actually realize they are the same thing. So there's no universal, you could say, taxonomy that represents the industry. So I think combination of these, and then you probably have specific, requirements for different regions, different requirements for, customers. So that whole, I think, couple of those reasons probably has led to that industry really not being able to really benefit from all of the innovation.
Right. Yeah. It's probably a good segue. You have this huge vision with Kimia of building chemical intelligence, but you haven't started by going directly into R&D. Tell us a little bit about like where you've started and why you've made those decisions.
Yeah, so even though I've got a passion and love for R&D, chemistry, formulation, because that's I guess the world that I really know a lot about, what we decided to do was actually start on the other side of this spectrum. So you have, I guess the chemical industry, maybe to give some perspective, works as a triad of manufacturers who invent, and then you have distributors who are kind of more of an enabler of, and then you have buyers, people who buy things and engineer them into products. So that whole thing is basically manufacturers, distributors, buyers. It's based on technical knowledge and technical know-how. Now, if you think about R&D, it's kind of at the beginning. And then you have commercial, which is once the product has been developed, you try and sell it and commercialize it. Instead of going in R&D, we start on the other side of the that chain. And I think the reason for that is we believe rather than trying to build a system that knows everything about everything, kind of like the Google DeepMind approach where massive amounts of capital is needed to create this kind of horizontal platform that understands everything about all the things around us. We believe it's much more efficient and timely, in terms of efficiency of time, to start with specific commercial problems in mind. So if you can create a system that understands the existing raw materials and categorize them, if you can build the right tools that can use that understanding and actually start solving problems through, deploying agentic workflows that, salespeople, commercial people, even R&D, people use. You create this like data flywheel. You start getting a lot of data because you're creating these tools. More tools gives you, the right to earn, again, more proprietary data. And then that's how you can kind of move down the chain with that understanding of, I guess, the real world. What matters in terms of regulatory. What matters in terms of different personas of people that are trying to buy, products as consumers. What matters in terms of supply chain. When you start with the R&D, you miss all of that because it's all about simulation and moving pixels on a screen, and you end up, spending a lot of time. So we believe this approach would give us a much better shot at, solving this problem at its core, and it's just much faster and much more efficient. That's what we're seeing already with the progress so far.
And what's next? So you're already working with some of the world's biggest chemical companies. You're solving problems for them. You're helping them make sense of tons of data that they have. Where do you go to from here, and what are sort of like the rough steps towards building towards chemical intelligence?
So when we think about, I guess, chemical intelligence, I think the 4 pillars that we believe we need to build, and we're on that journey right now. So number 1, like I said, was getting access to the world of raw materials and chemical data, what's existing already out there in terms of journals, patents, raw materials. Number 2 is being able to understand that data beyond just like answer engines and retrievals, actually reasoning, in true sense. Number 3, with those 2, you can then build tools and understand what kind of problems you can solve. Problems that are already being solved by humans. And you can actually end-to-end solve that problem more than just a productivity tool. You can actually get rid of, a whole function that used to take months to understand regulatory constraints and why we can't use this, solvent because it's toxic for the environment. You can actually, completely do that. And once you do those 3, you have a much better shot at scaling this comprehension across science. And that's when you can start thinking about robotics. And what we really believe is if you can build this chemical intelligence, CI, as we call it, CI can guide robotics that are working in harmony with chemists and real humans to actually start evaluating the decisions, iterating, and in the background basically have, if you think about the supply chain, products are being built, shortage of raw materials are already solved. When you wake up in the morning as a chemist, there's been a new decision made and a raw material substituted, and then all the way to sales and distribution. So that's the journey we're on right now, and we're building, bits and pieces of that so far with the partners that we have.
What do, at these big companies, what do their AI labs and R&D functions look like today? I'm sort of imagining people in white coats not really using much technology, like mixing things around. What does it look like today, and what do you sort of expect it to look like in 2035?
Yeah, I mean, today it's very manual, right? It's there's a lot of pen and paper and Excel sheets, which is why there's a lot of randomness. There's a lot of data that's buried into, I guess, the minds of, these brilliant minds of chemists who've spent years and years. Data trapped in PDF documents, Excel sheets, whatnot. And there's millions of journals and papers that are being published every single year. And there are no systems, there are no kind of accessible intelligence that is reading all of it, which is why, there could be two people across the world working on a very similar project for years and years, and they never know about each other. They can't work on, in parallel to each other kind of approach. So what that means is things take longer to build and formulate. Products end up being much, much more expensive than they could be. They've got a lot more ingredients than maybe they need to, which is why toxicity is now, becoming a thing, and everyone's thinking about how do we remove, things that could be harmful for the environment. So how that could change in the future, I mean, predicting the future is very hard. And with the rate of acceleration, it's harder to even think beyond 2-3 years. But what we believe is going to happen is every product, and by product I mean every chemical and material, will be touched by Kimia's chemical intelligence at some point in its life. That could be at the beginning when you're thinking about the creation and the discovery. It could be at the point where you're thinking about the regulatory kind of constraints of it, and then all the way to sales, distribution, and creating something much, much more sustainable. Once we can get towards that, I think the world will be very different. We'll have a chemically abundant world, and I think as people that are consuming, I think we'll be in a much, much better place. And I think the labs will just have to keep up. So you'll probably see a constellation of AI models with chemists in the loop. I think chemists will still be in control, and robotics, except we won't be making the same mistakes, and we'll have a way to actually learn from the 100 years ago, things that were done.
What does chemical abundance actually mean in practice for like the everyday human? There's a lot of talk these days about like microplastics and forever chemicals and things like that. But what does a world that is chemically abundant actually mean for like the average human?
Yeah, I mean, you can probably think of it in two different ways. One is individual people, and then one is kind of more high level in terms of cities, transport, government, infrastructure. I think if you double click on the first one, I see a world where you could basically have something like a 3D printer at your house, and you can make, your most favorite products that you need to use, anything from toothbrush to shampoos to, construction materials, exactly personalized to the way you want. Maybe face creams, for example, based on your skin type and everything else. That accessibility is about having intelligence and then being able, to apply it. Things could be 10 times cheaper. There could be multiple folds less toxic, and more accessible. And then if you think about, on the bigger side of things in terms of cities, transport, I think a world that's chemically abundant would look something like we could have infrastructure that lasts hundreds of years. Roads won't need to be, undergoing like road work as often because there's always something breaking, and there's, materials that are on electrical coatings that are, getting destroyed, and, that takes a long time to repair. And we can really start imagining how we want to build cities. Like we could actually literally say, hey, what is a problem we want to solve, and what is something we don't have that we can now build? So I think that's like, what isn't in much further out there. Like we could literally get there.
I want to talk about you for a second. You obviously have a PhD in chemical engineering, and you could be sort of spending your life doing research, working as a professor, but instead you've sort of decided to take this path where you're starting a company, selling into an industry that hasn't historically been a good buyer of software. Tell us about why you've decided to start Kimia and where that motivation kind of comes from.
Yeah, I think it's really beyond even technical and maybe ambition. I think, with the things that I mentioned about, the history of, my dad, how I was brought up, I think it's beyond technical and ambition. It's really about kind of just, I'm part of this story. Like, it's a continuation of a story that I kind of didn't even realize I'm part of. And you could say maybe I don't even have a choice, high level if you want to get into willpower, make it a bit deep and philosophical. But I think I just feel this responsibility to continue this journey, and what I saw come out of, the innovations that my dad was part of and the changes they made, how do we, times that by a million? And I think that's truly how you can make a difference, and how you could build new cities, and you can affect, the society and humanity at a much bigger scale. It's a very ambitious, probably, goal and target, but I think it's worth spending, my life on. Yeah.
It's a huge ambition. What sorts of people do you need on Team Kimia to sort of make it a reality?
So most companies in the world of tech usually look something like product design and engineering, plus or minus, ops and things. I think for us, we've got that fourth pillar, which is science. So I think it's very important to have people that have an appreciation of not necessarily being a scientist, a chemist, a physics, major, but just having the appreciation that there is a place for that in our life, and we're grateful to be, in a world where we're not dying because of, basic diseases. We've got a roof over our head that's not leaking, and it's not falling on our head. That's all because of progression and innovation. So our team basically has those DNAs in it. We've got some of the most brilliant minds in engineering, all the way to chemistry. People that have spent decades on the field, and once they see Kimia and once they got exposed to it, basically, one of them literally said, "Hey, I wish this existed 20 years ago when I was still in the lab." And now, even though they're about to retire, they've started a new career with us because they want to be part of the next thing, and they see that massive impact that this could have. 40% of the industry is retiring. So people that have this art, if you may call it, people like my dad, and that's going to leave a massive gap. So I think that's a real inspiration for a lot of the people that we've been able to hire and build this with.
There's a lot of talk in tech today, and Palantir sort of coined the term like forward deployed engineer. Do you sort of see yourself working with these chemical companies in similar ways, where you have a forward deployed team that's really like going deep with them and understanding their problems, or what's sort of the model you've built around actually delivering your product to them?
I think when I think about Palantir, I think the fact that they've got a narrow set of customers that are very different, right? You have government agencies to aviation companies to, hospitals and things like that. The way we work is quite similar in that we kind of immerse ourselves in their world. Like I said, the industries are quite diverse and different, and we get to know them essentially as a partner, and we become an extension of their team. So that includes, forward deployed engineers that understand the data models and the data structure and everything that they have, and using that, building this ontology that makes sense for them in their industry, in the way they like to operate. These are companies that are making hundreds of millions of dollars to billions of dollars. And I guess you could argue they've been doing this on pen and paper and Excel sheet, right? So there's a lot of room, to even help them grow. And I think that model of combining that ontology, which includes context of chemistry, that chemical intelligence really comes in to bridge that gap, plus what we call systems of actions. So how do you provide these agentic workflows that help people make decisions and actually carry work? Once you combine them together, I'd say that's when magic happens. And that's probably very similar to how, from what I understand, at least from Palantir.
I'd imagine that when you're going into some of these companies, they've probably heard a lot about AI, but haven't necessarily used it much and are maybe a little bit skeptical. What's the sort of first like magic moment or aha moment that they have when you sort of show them what Kimia can actually do?
I think as soon as they see it, we used to have, slides, that we went through during our sales process and talking about, the company and problems on, words on a slide. And this one time we just didn't have enough time to, because there was multiple demos scheduled, behind each other. So we didn't actually have, time to go through and prepare slides. And we just jumped straight into the product. And that was kind of like a aha moment where we've completely changed the way we talk about the company. We go through maybe one slide of, hey, this is who the company is. And after that, it's all about the product. And I think once people get the chance to imagine what is possible, and kind of be inspired on, hey, you don't need to work the way you've always been working, and this is not something that's going to take months and years, and it's not going to cost, some ridiculous amount of money. That's when, they kind of break that mold, and then from there, it's less about, hey, I'm concerned about AI and what could go wrong, to I know this is going to be part of my life. How do I make it work? And that's a completely different conversation, and it's a much more productive and, I guess, interesting conversation to have.
What are some examples of like ways that people are using it today and how they're getting value out of it?
Yeah. So I guess like I mentioned, with the mission of the company is to build chemical intelligence, and we want to do that to drive commercial growth. So if you think about the different workflows within a company that affect commercial growth, we inject Kimia's chemical intelligence across all of them. That could look something like helping a company, let's say, Tesla, who is trying to formulate any type of, leather or coating for their seats, and now they need a new type of ingredient. How do you help them identify the one option that is going to be suitable out of thousands of options, right? And then on the seller side, as a salesperson, as a commercial facing person, imagine you have this like catalog of 5,000 different SKUs, each SKU with hundreds of different attributes that could explain that product, and then you got to find the one needle in a haystack. The kind of permutation combination is, I guess, it's not even complex, it's just near impossible, right? So that's where we can bring chemical intelligence and apply it in that instant. And there's probably tens of examples like this where right now it's taking people a lot of time, days, sometimes weeks, sometimes months, to be able to find the right answer and move that decision. Because the world of chemistry requires a lot of these like small decisions that compound over time and everything. So if you can save that opportunity completely to not spend that time, it has a huge impact on commercial growth.
Yeah. Zooming out for a second, I want to talk about the importance of chemical intelligence at like a national level. Do you think this is something that countries and governments should be thinking about, and should they care about sort of owning the stack for chemical intelligence?
I'm not sure about owning the stack, but I think having access to it and promoting it for sure. I think in a world where chemical intelligence is running through supply chain and companies have access to it, what becomes important is no longer randomness and just discovery. It's having access to intelligence. And once you have access to intelligence, it's kind of like, hey, close your eyes and imagine what the world could look like. So I think governments can have a very important role in promoting that and actually being part of it, right? In a country, for example, like Australia, with the resources that we have here, I think this is one of the ways that you could start thinking about how we could onshore manufacturing again. If things cost 10 times less and they could be built 10 times faster, right? That will have a massive impact on the cost that it requires to run a manufacturing. Things that right now might not be feasible will become feasible, and that will, I guess, reduce dependencies on importing a lot of things when it comes to chemicals and byproducts of chemicals. So I think being part of that journey to build intelligence and have access and provide access, I think, governments can definitely play a big role in that.
This is a bit of a curveball question, but how are you thinking about the timeline for chemical intelligence? I know it's hard to predict because the advancements in foundation models are happening so quickly, but as you sort of orient your team around this goal, how are you thinking about the timelines for it?
Yeah, I think it's kind of like it's kind of like a similar question to, when are we going to get AGI, right? When are we going to have access to AGI? And I don't think it's going to be this one instant in time where we go from not having to now having. I think it's a journey, and we're on that journey. So, and I think it's one of those things where it's like it's on 0-1, right? And you can start seeing the benefits and the improvements and the efficiencies already, being proven with the proof points that we have already. So, I think, in the next couple of years, we will definitely see this become part of the fabric of how a lot of manufacturing and distributing companies see the world. And like you said, frontier labs and models are already thinking about, foundational models. And I feel like what the world thinks right now, which is the next frontier, is going to be robotics. I actually think there's a step before that. In our world, that's going to be chemical intelligence. Robots can run and do things, but they're going to be missing that reasoning and that understanding in certain industries. So that's what we need to build first. Once you have that, then I think robotics can really amplify that and hopefully get us closer to.
So chemical intelligence would be an input to robotic systems that are sort of operating autonomously in a lab?
Autonomously, or with humans in the loop. The decision making, a robot can probably think about moving its arm, but how would it know at what time, what amount of chemical, in what sequence, when should you increase temperature, decrease temperature, when should you increase pressure, when should you decant things and pour things. So that middle layer, you could call it the firmware, you could call it the brain. So imagine a robot without a head. That head is going to be chemical intelligence, and then the body is going to be all the mechanics, actuators, things like that.
And do you think that you guys will build your own labs and have chemists and robots working in harmony together? Or do you think about it more as selling the intelligence to existing chemical companies?
The way we think about, so, when I mentioned the pillars for, getting to chemical intelligence, number 4, being able to scale this comprehension, part of that is to be able to validate the data, because chemistry is real. It's beyond, simulation and imagining things. It's really, and you have to close the loop and close that feedback loop by testing things. And there's so much you could do by relying on, historical data. So that's definitely part of what we're working on, to be able to validate that data. And once you validate that data, you could do all sorts of interesting things with it, whether it's, like you said, robotics, self-driving labs, which haven't really taken off. And I think there seems to be, no end in sight in terms of when they'll, get in production and scalable. So I think those are some of the stuff that we're interested in, whether we partner with other companies or we become one of those, I think yet to be determined.
So in some sense, you would have like humans in the loop in a lab doing whatever the chemical intelligence model tells them to do and actioning it and sort of providing it feedback?
That's one model. I think another, interesting way would be to let the robots do the manual work. And as humans, we focus on the stuff that we enjoy and the creativity. So we become the minds that find the problems that are interesting to solve, right? What can we build that previously we had no option to even think about it? right? Everything you see around us was built because someone thought about it and they're like, hey, we can probably build this. But there's so much more that we haven't thought about, and we probably right now can't even think about it because, you know, it's like you don't know what you don't know. So I think with robotics, once we get rid of that kind of labor component of this, I think humans can stick to what they're good at, which is be creative and actually focus on, you know, the right problems to solve that benefit the society.
I want to ask you one final question, which is, where does the name Kimia come from?
Good question. So Kimia is basically means chemistry in the Middle Eastern and kind of Persian culture. Its root comes from the word alchemy, which means, I guess, transforming. So taking something that's just quite ordinary into something extraordinary. So when we thought about, you know, the mission of Kimia, we couldn't think of a better word that would reflect that. You know, taking this like messy, unpredictable yet beautiful science and transform that into something that's more programmable and intelligent. And I think if we can do that, yeah, we've achieved our mission.
Awesome. Well, thanks so much. This has
Thanks
been
for
great.
having me.